Okay, so we just finished finding the what happens at all these different spots here. Now what I'm going to do is put them all, and I'm going to actually zoom out for this. I'm going to put them all into the same plot. So I'll zoom in there in a moment, right? But take a look. This was the 4, 6 right there, right? So over at 4 up 6, I've got this. That's a copy of that right there, right? Oh, let me do. Um, I'm gonna put them all on the same grid, and then if the context allows us, we will ignore parts that we can ignore. For example, in this one, we're working with population models, so X and Y, they can't be negative, right? So I'm only gonna look in this scenario at the first quadrant. So let's zoom out a little bit. All right, what else do we have? This guy, that's 0, 8. So I'm going to ignore this spot right here because that's negative and do the 8 where it, right here, 0, 8, goes down to the right. That's the source part of it, or the positive eigenvector, and then it goes in and in, right? This one right here, you see, drawing that saddle piece doesn't really even matter, right? Because what am I going to do? I'm just going to transfer that to here, right? So this guy is that up and then a pair of ins. So up and a pair of ins. Okay. And then this one right here is at 0, 0. Can ignore the two negative parts, right? And just do the up and the out, right? Okay, so now I will zoom in a little bit. So that's step 4. Just put those onto the same grid in the correct spots where those critical points are. And step 5 is our last step, and all we do is just fill in the rest, right? So if you look here, this line would connect, or yeah, I'm going to draw it so that this line connects up to that line, like straight in from there. You may say, how do we know if it actually connects in? All right, sorry, got interrupted there for a moment. But I think what I was saying was that I'm just going to draw a line from here to here, nice smooth curve. You may say, well, how do I know that this piece is going to go into that piece? And my answer is that it probably isn't, right? But remember, this is like not exact, right? While that piece right there is probably not going to go into there, there's probably a piece that's very close to here because this is a sync node. Like there will be a spot that comes in and goes into something that is that's going to end there, right? If it starts right here, it's going to whoop and then end right there, right? So it's totally legitimate to just connect them. And I like to do that because I like to connect this like that and connect this into there because it looks good and it shows me what's happening in this system, right? I know that if I start really close to this critical value, if I start at the critical value, I do not leave it. You should understand that because the derivatives are about to be 0. X prime 0, y prime 0, don't move, right? But if I start a little bit above it, right, then I'm going to go whoop, and we'll end there. And if I start a little bit outside of that, I'm going to go and we'll end in here, right? So those are important lines to do. So those are the first 2 lines I do. This one, and then this one. The next line I'm going to do is when I see that I've got that kind of separating spot, right? I say, oh, look, I've got this guy. It's going to slide up to there, right? So I draw a line directly from here to there. Whoop. And then I draw this line right here, come down in, right? And then I say, all right, what pieces do I have to fill in? Well, I could zip up like this, up towards that spot right there, and then go down, and then get that one in, and then do these 2. And then I get all of these other ones that would flow into that spot right there. So let me talk about what all this means. Look, 4, 6, that is if you go back to if you think about what I said in the original spot, it seemed like there was a carrying capacity if one of the other ones was not there, right? So both of these have this negative piece, right? They're both very similar. What I get is a combined carrying capacity for this thing, right? At 4 and 6 units of population. Maybe it's 4,000 of one and 6,000 of another or something like that, right? It's not a like I have 4 elephants and 6 giraffes, right? Anyway, it is a combined carrying capacity here, right? So no matter where I start, right? Unless I start at one of those four, or one of this, this, or this, one of those critical points, or on one of these axes, I'm going to slide into that spot right there, right? 0, 0, that's a source, right? If I have a little bit of one of them, or a little bit of the other, or a little bit of both of them, then their populations will grow. That is the same as being in this region down here. If I start with just a little bit of population right there, it'll go up eventually. So, sorry, interrupted again. What I was saying is goes back to the original thing that I said right here, where if I get, say I was when I was doing this analysis of X, right? Get rid of the Y's, right? What do I get? I get logistic growth, right? I get this thing right here. I get a carrying capacity at 7 in this thing, and that's not totally right, is it? Oh, it is. Yeah. If I get rid of the Y's, um, uh, I have, is that right? Yeah. Anyway, whatever. If I get rid of the Y's, right? If I make Y equal to 0, right? Then then I am only on the x-axis. If I start left of that 7 with a population of x that's below 7, well, what happens? It creeps up until it hits this 7, and that's the carrying capacity. If I start to the right of it, above it, I'm not going to magically like get some y population, right? Um, uh, in, at least the equations don't let me do that. You could put a population in somewhere and see what happens, right? But it would sink in down to this 7 right here, right? There was just a little bit, slide, 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 and then it would get hooked and it would go up, right? So same thing here. So those are the carrying capacities for either of the species if the other one wasn't there. This would be like a peaceful coexistence model is what the book calls it, right? But um, uh, what this is all about, one, using these eigenvalues and eigenvectors and Jacobians and partials and everything, right? And figuring out what happens. But say I had this thing and I made the 14 a 20, right? Well, that's going to change some things. It's going to slide this guy out a little bit, right? Um, it's gonna is that gonna is it gonna pull this guy out a little bit? Is it gonna flip that from sink to maybe a saddle, right? So there's all kinds of things that can happen if I manipulate these things a little bit. Say I were to take the interaction rate and leave x like that and then change y so that y was a positive x plus y, right, sorry, that the y prime piece was a positive x plus y here. How would that change this system? Well, suddenly this one is the interaction rate hurts x's population, but y, if I make that a positive, the interaction rate helps that y's population. It adds to it. So that would flip to more of like where x would be a prey and y would be a predator. Just intuitively by looking at this equation, eventually you'll be able to see that, right? So what we want to do is create the phase plot and verify our intuition there. So there are all kinds of things I can change. I could like get rid of one term and see what happens, right? Maybe I get rid of the logistic growth part, get rid of this 2x squared. I wonder what that would do. Maybe that would get rid of this term right here, right? And make it so that we don't have carrying capacity for x. So anyway, that's what this is all about. You're going to do a ton of these, and I think that the more you do, the better you'll feel with them. So that's all for the video. I hope this helps and that you understand it and that it's a good follow-up to what you did the other day. And thank you very much.